This is a very quick video to show how to make the outer shell and perimeter for an egg chair. There will be two methods shown. The first method in part 1 of this video and the second method in part 2. What I'm going to start out doing is rolling the feature tree back so we can look at our sketches. And with this particular video, we're going to focus mainly on what the egg chair looks like from the side view and not from what it looks like from the top or the front views. I've spent a lot of time measuring an actual egg chair, and these dimensions should be within about an inch of what is correct. So what I'll do now is go ahead and edit the sketch. And I'm going to hide the curvature cones because these are a bit distracting. And what I found was that the chair is approximately from this point to the utmost back point is about 31 inches. There's some additional projection when you have the cushion on the seat, and I know that some people had data saying that the chair was about 34 inches deep from the front point to the back, but everything I've seen seems to indicate 31 to 32 inches. So let's look at some of the ways I drew this sketch. This line I was able to draw as a single spline, and I was able to make this point, which is almost the most outer point, tangent to a vertical line here. Later on I discovered that I needed to tilt the control handles just a little bit in order to flatten this area out. So if this is too curved in this area, you end up getting a lumpy chair. This curve represents the cross section of the shell on the mirror plane, which in this case is the right plane. This line represents the seam of the chair, which is actually in 3 dimensions normally. So the seam starts out on the mirror plane here, projects out toward us as it's coming down, and then returns back to the right-hand plane, the mirror plane, at this point. I've tried to encourage everybody to draw this line as a single spline, which is what I did here, but if I turn on the curvature combs, you can see that my combs aren't all that great looking. They should be more gradually changing shape, and they kind of radically jump up and down. It's not terrible, but if you want to draw this as multiple splines, I can understand why you would want to do that, not only to get this a little more smooth looking, but also when you have this many points on a spline and you try to adjust one point, it has a lot of influence on the other points. So if you draw this as multiple splines, don't just stop and start the splines at arbitrary places, stop them at some logical places. For example, you could make one spline going from this point to this high point and then to this low point. Wherever there's a high point or a low point, the handle should be horizontal. This area here, we go to a high point, to a forward maximum point, and then also to a vertical or a forward minimum point. Let me restate that. That would be the backmost point of this notched area. So these handles should be horizontal, this handle should be vertical, and this handle should be vertical. So you might be able to break this up into, say, 3 splines, one that goes from here to here, another that goes from here to here, and then maybe a little short one that's equal curvature at both ends, or at least tangent at both ends. That way you can adjust these handles without so much influence going throughout the rest of the spline. If you're really having trouble, I suppose you could go from here to here, here to here, and so on, but that's going to be a lot of pieces to your spline. Remember to make them at least tangent to each other and ideally make them equal curvature. The trouble is when you make them equal curvature, sometimes that makes it difficult to adjust the handles also. If you have trouble adjusting the handles, sometimes you can add a dimension to the handle and then tweak the length of the handle by changing the dimension. Over here, this handle originally started out vertical, and I needed to flatten this area out a little bit more, so I actually tilted it out by a few degrees, which made this area look nicer. These dimensions are reasonably accurate. While you're building yours, you'll probably find that you're going to be tweaking the dimensions a little bit. So stick with whatever you've originally measured, but be willing to change things a little bit here and there by as much as an inch, especially this dimension from here to here, which I think is somewhat accurate on drawings on the web. If I zoom out a little bit, I was measuring everything from a baseline, which would be where the floor is. At the moment, I have the floor at a very arbitrary place because I borrowed this sketch from an earlier student sketch who had the chair somewhat arbitrarily placed. So I just made the base 5.5 inches below the lowest point of the seat or the outer shell. You'll also notice I put a length dimension on this entire spline, which comes out to about 59.7, almost 60 inches from this point all the round way to this forward point. And that's about what I actually ended up measuring on the real chair. This is gray, so this is just a driven dimension. I will also mention that this forward-most point of the headrest area is a little bit lower than the high point of the back seam, about 3/4 of an inch lower. The key to making this a successful looking chair that's nice and smooth is trying to get these curves as rounded out as they possibly can be, especially in this area here where the surface tends to want to pinch. So this should be nicely rounded in here, almost like a quarter circle. So I'll move on now so we can look at the rest of the model. I put a sketch plane almost at the top of the seam, but later on I decided it was better to move that plane down to this forward point of the headrest wings. The next plane I put in was the high point of what I'm calling the side bolsters. These bolsters are on either side of your legs, of course. And I'll mention that I put in this sketch to control the location of some extra planes that are ending up in some arbitrary locations. I have a plane here that I call the low point of the bolster. It's a little bit of an angle. I ended up never using that plane. Then I have a plane that I call the notch plane, and this is at about 40 or 45 degrees here, so it's kind of coming through the narrower part of the shell. Then I have a plane that I call the shoulder plane, which is a little bit below this highest plane. And again, I, in this case, did not end up using it. So what I'm going to do now is put the feature tree into the flat mode so I can see all the features in their original order of creation. So I'm going to show flat tree view. In this way, I won't see any features indented underneath any other features. So we'll ignore this shoulder section that I'd made. In order to make my shell, I decided I was going to make it as a boundary. So I copied this bottom line and I stretched out the tip a little bit, and I tried to stretch the top out so that it would go above this point, but when I did, it curled funny, so I just added a little extra piece that's just a simple arc, and I tweaked it until it looked like the curvature was similar to the curvature of this portion of the back. So we'll take a look at what the cross sections look like. I'll hide any that I ended up not using, such as this one here. And the primary ones I used were the one up at the topmost plane, the one on this tilted notch plane, and one on this bolster plane. And what I actually did was I measured the chair as carefully as I could in order to figure out what these curves should look like and how wide they should be. Of course, I've only drawn 1/2 of the chair. I'll start with this upper curve. And what I found was the distance between the wings up near your head is 33.5 inches. And I took a measurement with a tape from the center of the chair all the way around to the tip of the wing, and the length of that was about 21 to 22 inches. And I just kept tweaking this to get it to look right. So you can add a length dimension to a spline. When you do that, you can only control one of the handles, and the other handle gets controlled automatically. So I'll demonstrate that just by, I'll delete this dimension for a moment. And if I pull on this handle, you can see that the other handle is moving automatically. That's to maintain this length dimension. If you're wondering how to add that, I'll just delete this for a moment. All you do is make a dimension, click directly on the spline, and it makes a length dimension for you. So if I turn on the curvature comb, what I did was I just kept tweaking this handle until the curvature looked reasonably even all the way around. So it's not quite a circular arc, it's a little bit more oval shape. And you can see here that it's getting a little bit of tighter in the curve at this corner. I ended up having to tweak these dimensions quite a bit in order to get the chair to look good. So you can kind of start out with these, but you'll probably find yourself messing around with them a little bit. I would try to get as close as 33.5 as possible, though. Moving down to the next one, this is at the notch. At that notch area, I found the chair was about 26 inches wide. And again, I applied a length dimension of, in this case, 18.5 inches for 1/2 of the notch. This was probably a little bit greater than in real life, but again, I had to tweak this to get this area to look good. The important thing on all these curves is we don't want them to go backwards on themselves. We want them to sort of be opening up. So you see here I have a 12-degree angle on the tip of this spline, and on the previous sketch that I showed you, I think it was at 17 degrees. Finally, we get to the bolster area, and the chair is about 31 inches wide there. Again, a length dimension. I think this one might be the most inaccurate that I kept messing with until I was happy with the shape of the chair. And again, you see how this is opened up at about a 13-degree angle. So you're going to be playing around with that a lot too. So to make the shell, what I'm trying to do is just get a primary surface that does not worry too much about what the outer edge is going to look like. To do that, I'm just making a boundary that's going to use this stretched line that I showed you earlier, and these 3 cross sections. So when I do so, I get a surface that looks like this. And it looks a little funny in this area, and I purposely made it overshoot the end of the chair, or rather the front of the chair a little bit, and it's a little bit higher than the top of the chair. Now you see here that the perimeter goes out farther than the actual surface that was just created. I'll also mention, of course, that this surface has to be normal to profile on this edge here, and that's the only control that you end up making on this feature. So we'll just take a look at the feature manager for a moment. Just one line in direction 1, and my 3 cross sections in direction 2. And we can see that this is set normal to profile on direction 1, and I bumped the tangency up to 100%. I didn't really see much difference when I changed that. So going back to our side view, we need to get this surface a little farther up so that when we trim this edge, we will not have any gap in here. So we'll just simply use the surface extend command. All I did was pick the edge extension, and I clicked on this edge and extended it about 3 inches so that you can see that the edge of the surface now is beyond the red layout sketch. So all I have to do now is copy this layout sketch and use it to trim away all this excess material, and that's going to give me my shell. So I've copied my sketch. I use that for a standard trim. I decided to keep this portion here, which is eliminating all of this bluer section. And that is my completed outer shell for the chair. If I rotate this around, it looks pretty good. You can see a little bit of a shadow in this area. And you see how it kind of tucks in a little bit in this area. So this is where you end up doing a little messing around with some of the dimensions to see if you can improve that. Now if I show the front view, we see that we can see most of the perimeter. The perimeter goes a little bit behind the bolster from the front view and then comes back into view in front again. I'm not sure if this is correct in real life, but it's pretty close to being right. If we look at the top view, we can again see the perimeter coming down. The upper edge occludes the lower edge a little bit, but it keeps coming around and then finally to the seat area. So this is a pretty reasonably accurate shape. So what we've done is we've created a three-dimensional surface, and by trimming it just in one direction, that gave us the look of the chair from the other two directions without having to know ahead of time exactly what that perimeter looks like from those directions. So that's the advantage of this approach. However, this approach sometimes causes you to get a chair that looks a little bit lumpy. This looks good from the front, look good from the top and the side, but if I rotate it a little bit, 1, 2, 3, looks good there. From this angle you see a little bit of a bump. I consider this to be totally acceptable, but on earlier trials I had a very generous bump here that just did not look very good. And if that happens to you and you cannot seem to get rid of it by tweaking the other sketches, what you might have to do is add another section sketch to try to pull that bump in. That's also a little dangerous because when you add more sections, sometimes you end up adding more of a lump or a wave than what you end up taking out. So you might recall that I had some sketch planes that I had not used. There was the one at the shoulder and the one in the notch, the lower bolster area near the notch right here. So you might be wondering, if you are going to put another sketch in, how do you know what the shape of that sketch should be without having to do a tremendous amount of trial and error? So I'll show you a little trick that I've used before, and let's just say that we want to add another sketch in this area on this shoulder plane. So I will make a sketch on that plane. What I'll do is do an intersection curve of my shell as it is currently shaped. So that's the shape of the shell. We're going to use that as a reference to help me tweak the shape of this shell overall. Now what I'd like to do is move it farther up the feature tree so that I can use this reference to draw a new cross section and put that cross section into my outer shell boundary. The trouble is, this shape is dependent on the existence of the outer shell boundary, so I can't move that sketch higher in the feature tree than the outer shell. So all I have to do is click on this intersection that I had made, go to Display, Delete Relations, and just simply delete the intersection of two faces relation, and now it turns blue. And now I can move that sketch somewhere up here before the creation of the shell. And now I can go roll back a little bit, and I'm going to go back to that sketch. We'll look at this from the top, and let's just say that this cross-section was bulging out more than we wanted it to. What I'll do is just make this a construction line, or I could just do this on a completely new sketch and not do this new sketch in the same sketch as this line. And then I'll just draw a brand new spline. I'll probably want to add a dimension to it here. I'll make it horizontal here. And by using this as a guide, and I know that I want it to be bulging out a little less in this area, in my fake scenario here, I could just tweak the handles to bring this edge in a little bit. Now imagine if you didn't have this information, you wouldn't have any visual reference as to how to draw this brand new sketch that you want to use to pull that bump in. So this gives you a great reference for doing that. You can see where you were before and where you are now. I don't know what effect this is going to have on my boundary. Just for fun, we'll go ahead and put that in. I'll add that to direction 2. That would be this boundary that was just, or I'm sorry, cross-section that was just created. And now we'll turn off all of our sketches. We'll look at this from the front view and then slowly rotate this. And you see that I probably made it worse. I haven't trimmed it yet, so let's see what happens when I trim it. And I probably sucked this in a little bit more than I should have. So in this case, that was probably unnecessary, but I'm just using this to demonstrate the process. Okay, I've gone ahead and deleted that extra sketch and gotten back to where I am, and I just want to show you what the end game is going to be on this chair. So this shell was the hardest part to make. If you can get this reasonably smooth, a little bit of tucking in this area, as you can see on this one, is perfectly fine. A very subtle shadow through here is probably okay too. You want to kind of roll this around, make sure this surface is well rounded all through this area. One thing I do is look at this from the top and then use my arrow keys to kind of roll the part like this. In one of my iterations, I didn't do my cross-section properly, and when I rolled it, I suddenly saw that one of the cross-sections was very pinched and pointy. So if you see that, you're going to have to go back and fix that. So this isn't too shabby, and when you go to render this, if you use some sort of a cloth or something when you make the render, any little funny shadows probably won't be very noticeable. So what's the final thing to do? This is the outer shell, but we also have an inner shape that's going to be the actual seating surface, and it does not really follow this outer shell. So I'll just very quickly run through what's going to happen there. This sketch should probably be in your layout, but I just drew it by hand for the purposes of this video. So this would be the shape of the seat. We're later on going to offset it outward to add some thickness to the cushioning. And I'm going to take that shape and extrude it outward, and this is going to be a temporary surface for making a fill surface. I've added a new cross section here at the bolster. It goes horizontal right here. A cross section at the top. In this case, I put it in the shoulder area. I probably should have put it up a little bit higher. And then finally a cross section in the notch area. And that allowed me to make a fill surface that bridges from this outer perimeter to this edge here, which has been set to tangency. And here we have our seating surface, which looks pretty good. It's not lumpy or anything. And what we're going to do, let me just hide this. To make the final surfaces for the chair, we actually want to offset this surface out a little bit, about 1.5 to 2 inches. You're later on going to trim this back by using the trick where you sweep a pipe shape and trim it back, and then you're going to build a transitional surface that's going to take this cushioned surface back to the seam. That was in one of your tutorials. You're also going to take the shell surface and maybe just offset it back a very tiny amount, maybe no more than 1/4 inch. Do the same trick where you trim back the edge and then build up a transitional surface going to the seam again. And then you'll have a chair that looks like it's got some cushioning on the inside and a tiny bit of cushioning on the outside. And that pretty much is going to be all the hard work for doing this chair. If you can get this surface right, you're pretty much 3/4 of the way doing all of the hard work. Just for fun, let me hide this, and I will mirror this and hide that. Get a sense for what this chair is going to look like when you're all done. That's it for the first method, and then I'll make another video showing the second method for creating this outer shell.